Propositional equivalences. In this lecture, we present the concepts of logical equivalences, using De Morgan's laws, constructing new logical equivalences. The outlines of this lecture are Introduction to the major goal of this lecture, logical equivalences, using De Morgan's laws, constructing new logical equivalences. Introduction. An important type of step used in a mathematical argument is the replacement of a statement with another statement with the same truth value. Because of this, methods that produce propositions with the same truth value as a given compound proposition are used extensively in the construction of mathematical arguments. Note that we will use the term compound proposition to refer to an expression formed from propositional variables using logical operators such as P and Q. A compound proposition that is always true, no matter what the truth values of the propositional variables that occur in it, is called a tautology. A compound proposition that is always false is called a contradiction. A compound proposition that is neither a tautology nor a contradiction is called a contingency. Consider the truth tables of P or not P and not P. Because P or not P is always true, it is a tautology. Because P and not P is always false, it is a contradiction. Logical equivalences. The compound propositions P and Q are called logically equivalent if P, if, and only if Q is a tautology. The notation P is congruent to Q denotes that P and Q are logically equivalent. Show that not P or Q and not P and not Q are logically equivalent. The solution of this example given by the following table of truth values. Because the truth values of the compound propositions not P or Q and not P and not Q agree for all possible combinations of the truth values of P and Q, it follows that not P or Q is logically equivalent to not P and not Q. Example 2 illustrates that of not P or Q and not P and not Q are logical equivalents. This logical equivalence is one of the two De Morgan laws. Show that P or Q and R and P or Q and P or R are logically equivalent. The equivalence not P or Q is equivalent to not P, and not Q tells us that the negation of a disjunction is formed by taking the conjunction of the negations of the component propositions. The equivalence not P and Q is equivalent to not P, or not Q tells us that the negation of a conjunction is formed by taking the disjunction of the negations of the component propositions. Furthermore, note that De Morgan's laws extend to for any three propositions A, B, C, we have for any three propositions A, B, C, we have the following statements. For any three propositions A, B, C, we have the following statements. Using De Morgan's laws. Use De Morgan's laws to express the negations of Omar has a cell phone and he has a laptop computer, and Hend will go to the concert or Sammy will go to the concert. Let P be Omar has a cell phone and Q be Omar has a laptop computer. Then assessment, Omar has a cell phone and he has a laptop computer can be represented by P and Q. By the first of De Morgan's laws, not P and Q is equivalent to not P or not Q. Consequently, we can express the negation of our original statement as Omar does not have a cell phone or he does not have a laptop computer. Let R be Hend will go to the concert, and S be Sammy will go to the concert. Then Hend will go to the concert or Sammy will go to the concert can be represented by R or S. By the second of De Morgan's laws, not R or S is equivalent to not R and not S. Consequently, we can express the negation of our original statement as Hend will not go to the concert and Sammy will not go to the concert. Constructing new logical equivalences. Now, we will give another way to prove the equivalences of compounded proposition without using the truth tables. Such way is by using the known logical identities, we can establish new logical identities. Show that not P implies Q is equivalent to P and not Q. Solution. By the conditional statement, P implies Q is equivalent to not P or Q. Thank you.